Evening and welcome to the session 7 of Ellipse. In this session, we will solve some problems, okay, based on whatever we have discussed so far. So let us see the first question. So we want the least distance between the point on this, and there is a line x plus y minus 6 is equal to 0. So that means what? There is an ellipse here, which is x square over 6 plus y square over 3 is equal to 1. And then there is a line. So basically, it's like this. I have an ellipse here, and then there is a line x plus y is equal to 6. So this line would be lying, of course, it won't be intersecting, otherwise the least distance would be 0. So this line must not touch the ellipse. So we want the least distance. Okay. So what we will do, we will take a point on this ellipse. So let p root 6 cos theta, comma root 3 sine theta, okay, be a point on the ellipse. Be a point on the ellipse. So now we can do is we can find the distance of this point from this line. So d will be equal to what? So we can just plug in here. So I'll be having root 6 cos theta minus plus root 3 sine theta, and then minus 6 upon square root of 2. 1 square plus 1 square, so that's 2. And now we have to minimize, we want the least distance. That means we need to minimize this distance basically. So if we consider this guy, then we know that if I have here, say, a cos theta plus b sine theta, then this always belongs to what? The square root of minus a square plus b square, 2 square root of a square plus b square. So we can consider this part. And now what we can do is we can have root 6 cos theta plus root 3 sine theta, then minus 6. So minus 6 means that's a constant. So I can just add it here, or else we can directly do like this. This belongs to minus square root of this plus this, which will be 9. So we get here 3, and then 3 to 3. This, and now we have here minus 6. So therefore, what we will do, we will subtract minus 6 from this entire equation. So I'll be having here minus 9 to minus 3. That's what I get. Now, since this is talking about the distance, this guy is talking about the distance. So for the distance, what we can do is we want anyway the least distance. So least distance would be simply here, because see, this is basically modulus. So we want the maximum distance could be what? Okay. So therefore, least distance d would be equal to simply, if I take its modulus, because we ultimately know its distance. So this is going to be 9 by root 2 and 3 by root 2. So we have here 9 over root 2 and 3 over root 2 are there. So we want the least distance. So least distance we can see from here. Okay, so obviously this. So therefore, least distance would be 3 over square root of 2. Okay, so in this case, a ray of light passing through minus 3 comma 0 is incident on the ellipse. So the ellipse is x square over 16 and then 400 here. So we can write down here 25, and then y square over 60 would be equal to 1. Now we have a point on this ellipse. Let's take this way. So suppose this is the ellipse here. Now these are the two foci. So one of them is said to be this minus 3 comma 0. So let us see what's the foci here. So for this we need to find the eccentricity. So the eccentricity would be 1 minus b square over a square. It's 25 minus 16 is 9 over 25. That means e is going to be 3 over 5. So from here we can get foci, coordinates of the foci is going to be plus minus a comma 0. That means from here we can add on plus or minus a. It is 5 into 3 over 5 comma 0. So we get the foci to be plus minus 3 comma 0. So that is, this one is minus 3 comma 0. This right here is 3 comma 0. Now we have a ray of light which is passing through minus 3 comma 0 is incident upon the ellipse. That means this is incoming light. And now at a point with ordinate 4. So this is my point here whose ordinate is 4. That means y coordinate is 4. So, and then find the equation of the reflected ray. So we know the property of reflection. So by the property of reflection, what will happen? The ray which is incident and passes through one focus gets reflected and passes through the other focus then. That means we basically get this point. And once we have this point, we can use a 2-point form to get the equation of this reflected ray. So this is incident here, and this one is reflected ray. So the main twist here is that the reflected ray would pass through the other focus. So reflected ray would pass through the other focus. That is 3, 0. So now this point we need basically that point P. So for point P, we know that y is 4. So we have here 16x square plus 25 into y is 4. So I can have here 4 square again is equal to what? 400. That means I get 16 x square plus 25 is equal to, this is 400 over 16. Directly we can take it common. So this will give me 25 again. This is quite strange. So I'm getting x square is equal to 0. This is not possible. Our point should not be here basically. So this reflected ray actually incident directly here at this point. Can try it again. Yeah. So this is basically meeting here because x is 0. So this point will be directly hitting here. So we just want this distance. That means this is going to be 0, 4. So for in this case, we're going to have the equation of reflected ray. So this is 0, 4, and this is 3, 0. So therefore, the equation of reflected ray we can use the 2-point form. So I'll be having here x over 3 plus y over 4 is equal to 1. So this gives me 4x plus 3y is equal to 12. So coming to the next problem, so we have AB is a focal chord of this ellipse passing through the one focus, and S dash B is at the focus, then semi-perimeter of triangle S dash AB is what? So let's draw the diagram for this. So we have here x square over 16 plus y square over 16 over 9. This is 1. And then we get to see here AB is a focal chord. That means we can just draw the diagram here. So it will be looking like this. This is my ellipse. And then AB is a focal chord. So this is my AB. Let's name this A and this one is B. And now passing through one focus. Let AB focus passing through one focus, and S dash B is other focus. This is S dash. This one is S. This one is S dash. S dash B with other focus. The semi-perimeter of triangle S dash AB is what? So we want to find out the semi-perimeter of this triangle S dash AB. So if we want the semi-perimeter, okay. So for this thing, we don't have to do anything here, because if you watch carefully, then in the by the definition of ellipse itself, we had derived this thing. So if I take a point P here and then this distance, so this one and this one, let's say this is my point P and this is S and this is S dash. So SP plus S dash P is nothing but 2A. We know this thing. So what I'll do, I'll apply this one repeatedly here for point A, because ultimately we want the semi-perimeter. So semi-perimeter, we can think of this thing. That means A as S dash. I'll apply once, and then same thing I'll do for this. That means if I write down here BS plus P dash S. So this is again 2A. And for this thing, AS plus AS dash is again 2A. So that means semi-perimeter would be, first let's find perimeter. We can take care of semi thing later on. So perimeter would be simply the addition of yellow and green. So the perimeter would be 4A in this case. So semi-perimeter would be 2A. Semi-perimeter would be 2A. Semi-perimeter is 2a. This is nothing but the length of major axis. So the length of major axis. So length of major axis would be simply a is 4 here. So it's going to be 8. So semi-perimeter is going to be simply 8. That means from here we can have another property that if AB is a focal chord, and if I take here S dash, then semi-perimeter of this triangle would be always length of major axis. Without thinking for a second, we can answer this. Come to the next. So to say that, find the set of all values of lambda for which this equation represents an ellipse. So we have here equation 5x minus 1 square plus 5y minus 1 square is equal to, this is lambda minus 1 square into 3x plus 4y minus 1 or 2. 3x plus 4y minus 1 square. So we'll take here 5 common just to bring in the standard format. So this is going to be 25 here, and then I'll be having x minus 1 square plus y 1 by 5. Y minus 1 by 5 square is equal to lambda minus 1 square into 3x plus 4y minus 1 square. Now, if I take the square root on both sides, then this is going to be 5 here, and then I get square root of x minus 1 over 5 square plus y minus 1 over 5 square is equal to, this is going to be modulus of lambda minus 1 into modulus of 3x plus 4y minus 1. Now, politely, we can do here, we can take this 5 down. So this 5 I'll be writing like this, 3 square plus 4 square. Because if you watch it carefully, this looks like there is some fixed point, there is some variable point, p say x comma y, and then there is a fixed point which I would say here 1 by 5 over 1 by 5. So this distance, and this distance is from some fixed line. So this is my line 3x plus 4y minus 1. And this turns out to be the eccentricity. So this is nothing but basically SP is equal to E into PM. So if this is an ellipse, so if star is an ellipse, so if star is an ellipse, then what should happen? That mod of lambda minus 1 should be less than 1, and it should be, of course, more than 0. So now we'll be solving this one. So mod of lambda minus 1, mod is always positive, that means we have to take care of, it should not become 0. So mod lambda 1 should be less than 1, so I have here minus 1 less than lambda minus 1 is less than 1. So I get 0 less than lambda is less than 2. So this is the point. So therefore, lambda belongs to what? 0 to 2. And since this is more than 0 always, that means lambda should not be 1. So I'll remove 1 from this. So this is the point. This is the set of all values for which this equation would represent an ellipse. Coming to the next one. So here we have the foci of an ellipse and the hyperbola will coincide. Then the value of b square is what? So here we are going to use two results. Okay, this is orthogonality of ellipse and hyperbola. So orthogonality of ellipse and hyperbola. So the fact is that E and H, we say E and H. So E and H are confocal if and only if they are orthogonal. That means what? If they are orthogonal, okay, they are confocal. If they are confocal, they are orthogonal. Confocal means having same foci. Having same foci. And orthogonal means they are at right angles. They intersect at right angles. So orthogonality of angles, orthogonality of two curves, we check when they intersect at 90 degree at all the points of intersection. So now we are saying that they're confocal. So the condition for the orthogonality, of ellipse and hyperbola. So the condition of orthogonality is if you have the ellipse E is equal to x square over a square plus y square over b square is equal to 1. And let's say your hyperbola is x square over a square minus y square over b square is equal to 1. Let me not use a and b. Let's rather use some standard different notation. Otherwise, it's a bit confusing. So I'll write here some c square and d square. So the condition of orthogonality is this. You see here, it is a square minus b square. For ellipse, you should write minus, and for hyperbola, you should write here plus. This would give you the condition of orthogonality of ellipse and hyperbola. Now, once this is done, then there is nothing in this problem. So you have x square over 16 plus y square over b square is equal to 1. And this one I'll multiply by 25 first, and then I'll be bringing 125 down by writing like this. So y square by 81 by 25 is equal to 1. Now this gives me 16 minus b square is equal to 144 plus 81 by 25. So 144 plus 81 will give me 522 over 25. So this is 25. So now we see here this is 25, and then 225 will be divisible here. So I'll be having 9 here. That means 16 minus b square is 9. So this gives me b square is equal to 7. So the answer would be 7. Come to the next one. So we now have a line passing through the point P, root 5 comma root 5, intersects the ellipse, this one at A and B, such that PA into PB is maximum. Then 5 times PA square plus PB square is what? Of course, let's take an ellipse here, like this. And now we are saying that there is point P root 5 comma root 5. So let me place these values here. So this is 6 comma 0. This is 0 comma 5. So S1 I'll check. S1 is 5 over 36 plus 5 over 25 minus 1. This is less than 1, less than 1. And they both don't add up more than 1. That means this is negative. That means root 5 comma root 5 is basically lying inside the ellipse. Now there is a line which passes through the point this and intersects the ellipse at A and B, so that P into PB is maximum. So we can have many lines like this, okay, which are passing through this point, and they will intersect the ellipse at 2 points, like this. So our concern is we are saying that PA into PB is maximum. So in this regard, if we consider here, okay, in this regard, if we consider there is some point P here, and I want this length to be maximum. So of course, the maximum length we get only when the line here is what? Parallel to the major axis, because this is where it will, this length would be max, and this also would be in terms of PA and PB. So we want this is P, this is A, and this is P. So it's going to be maximum. So PAP, PA into PB is max when the line is parallel to x-axis. So when the line is parallel to x-axis, that means we know the b, y coordinates of B. So it's going to be root 5, and coordinates of A also we know it's going to be root 5. And coordinates of P we already know it's root 5 comma root 5. So what we can do, we can solve the ellipse with y is equal to root 5. So because we want the x coordinates. So x square over 36 plus y square, y is basically root 5. So root 5 square by 25 is equal to 1. And then this is x square over 36 is equal to 1 minus 1 over 5. This gives me 4 over 5. So from here we get x square is equal to 36 into 4. Let's not multiply later. From here we get x is equal to plus or minus, this is 6 into 2 is 12 by root 5. So we now get both the points. So point here is going to be, this is minus 12 by root 5, and this one is 12 by root 5. Now we want PA square plus PB square. So we can directly get it. PA square. PA square would be what? This distance I want and this distance, or else we can use the quadratic method. So PA plus PB the whole square minus 2 times PA into PB we can do. So PA plus PB is nothing but A to B distance. So we know this is minus 12 by root 5, this is 12 by root 5. So I get only 24 by root 5 square directly. And then minus 2 times, this is going to be PA into PB. So we need to find out using distance formula. So PA into PP would be the square root of this into square root of this. So this is root 5 is fixed. So I'll directly get root 5 plus 12 by root 5 square. And then into, oh, okay, this is also another result only. So root 5 minus 12 by root 5 square. So this gives me 5 plus 12, 17 square, which is 289 means 17. And 5 minus 12 is 7 square is 7. This over 5. So this gives me 119 over 5. So 119 over 5. That means I get 24 square is 576. And then minus 119 is 238 upon 5. So we'll multiply by 5. So from here I get 576 minus 238. So 16 minus 8 would be 8. And 6 minus 3 is 3. And 5 minus 2 is 3. 338 by 5. So answer would be 338. Coming to the next. So it is said that center of ellipse is at the center. So the center of ellipse C is at the center of ellipse E, where A is more than B, and C passes through the foci F1 and F2 such that the circle C and the ellipse E intersect at 4 points. And P be one of those 4 points. If the area of triangle PF1 F2 is 30, and the length of major axis is 17, then the distance between the foci of E. All right. Let's draw this ellipse first. We'll get the complete idea what exactly we do need. So we have an ellipse here, and then there is a circle which is intersecting at 4 points. So let me draw a circle like this. And this ellipse, this circle passes through the foci. This is F1, this is F2, I'll call. And P is one of the 4 points. That means we can take any one of them. So this is P, suppose. Now they are saying that the area of this triangle is given PF1, F2 is 30. All right. So if we consider the equation of circle, so equation of circle, we can easily get it. Say my circle is centered at 0, 0 by this definition. And this circle is passing through the foci. That means this guy is acting as the radius. O to F2 or F1 we can consider. So the radii is nothing but the foci. So foci is AE. That means equation of circle, we can directly write down x square. Okay, x square plus y square is equal to AE square. This is going to be my equation of circle. And equation of ellipse would be, so equation of ellipse we can get, it's going to be x square over a square plus y square over b square is equal to 1 as given. Now we are saying that area of this triangle is 30 given and length of major axis is 17. That means we know that 2a is what? 17. So we have this much information. So what we can do is we can take a point P on the ellipse, or say it's on the circle, of course, and then we can use, we know F1 and F2. I guess no, that is not given, but no problem. F2, we know at least a comma 0. This is going to be minus AE comma 0. So area of triangle, we can get it like this. Area of triangle will be half of this determinant, which is, let's take this point first. So it's going to be AE cos theta, comma AE sin theta. This is the point on the circle. R cos theta, R sin theta. So R is this. That means I'm now going to have here AE cos theta, and then AE sin theta. And then the next part is also ready. That is AE comma 0 minus AE comma 0. 1, 1, 1. This is going to be what? 30. So from here, we can take AE common from this and AE common from this. So I get half A square E square into the determinant cos theta 1 minus 1 sine theta 0 0, and this is 1 1 1. Now we can just open this. So we end up getting half of a square e square. In this determinant, I'll expand from this row. That means this is minus plus minus. So minus sine theta, and it's ultimately this modulus, so no point. So this is sine theta into, this gets cancelled. So we get 1 plus 1 into 2. This is equal to what? 30. So this 2 and 2 I get cancelled. So I get basically a square e square into sine theta is equal to 30. But it's a very bad thing because ultimately we wanted the area. So area height of this triangle would be simply a sine theta, not a square e square sine theta, but not a problem. We can do one thing. We can solve for a point of intersection better. So we have circle, we have the ellipse. So solving circle and ellipse. Solving circle and ellipse. So that is there is no point of all these things. Let's remove them. So if I solve circle and ellipse, I get this is x square plus y square is a square b square. So basically, we have to make sure that first, what do we need here? Okay, this would give us the standard result. No, we need f1, f2 basically. So we cannot use even pf1 plus pf2 is 2a, because ultimately this will give me the same thing. So let's go ahead. Here it would give us pf1 plus pf2 is 2a. So a minus 1 minus cos theta. No, not required. Let's go. So x square plus y square is equal to a square e square. And we have the ellipses x square plus, we can write down here, a square y square by b square is equal to a square. We can subtract. This gets cancelled. And I can take y square common. Why are we solving for y? Because we want to get the height. Okay. Height is there, then we know the base, and area of the triangle we know. So this f1, f2, if I use, then f1, f2 is nothing but the distance between the foci, which is acting as the base of this triangle. That is my goal. So I solved for the first time. I thought a sine theta I can have, but this gave me a square, e square rather. So y square would be, y square is common, and I get 1 minus a square over b square is equal to, I can take a square common, and this would give me e square minus 1. Now let's see here, what do we do? Okay, something at least we're getting here. Let's come see square minus 1. Now, if you see here, then this is basically what? Y square into b square minus a square upon b square is equal to, a square is there only, and e square is nothing but 1 minus b square by a square minus 1. So this minus 1 gets cancelled. A square also gets cancelled. And this minus, I'll finish it by writing y square is equal to b to the power 4 upon a square minus b square. So I get y is equal to b square by the square root of a square minus b square. So I get this. Now let us use something and see what do we get. So area of this triangle is 30. So this distance, I get here half into base is basically what? 2ae. Into height is simply this. So this is b square by root of a square minus b square is equal to 30. So this 2 gets cancelled. And this is a. So a, and then here this is b square, and then from here I can take a common. So this would give me 1 minus b square by a square, which is again 30. That means this a cancels, and this is nothing but e. So this also got cancelled. So I get b square is equal to 30. Okay, so now we got b square is equal to 30. And what do we need? We need the distance between this. So we have a, already we know. So distance between them is 2ae. So 2ae is equal to 2a, and e is simply what? 1 minus b square by a square. So 2a is given to be what? Length of major axis is given 17. So we can add on here 17. I think there was no point of doing this thing because we don't have, we can get this cancelled anyway because a will come out. So a square minus b square. We ultimately have got it. So 2a is, keep 2a here only. And this would give me square root of a square minus b square by a. So a gets cancelled. That means this is a gets cancelled. And this will be 2 times root of a is what? So, oh, okay. So 2a is 17, so a is 17 by 2 square means we should write here 17 square by 4 minus b square is already 30. So 17 square minus 120 over 4. So this also 2 also gets cancelled. We get just simply 289 minus 120 is nothing but 169, which is 30. So the answer would be 13. We could have got this way also. Nice. Coming to the next one. So this problem is asking us to find this sum basically, and then what do we have here is E1 is, there is an ellipse here. So let's draw this ellipse first. So I'm having one ellipse like this here. So this point is 3, 0, and this is 0, 2. This is 0, 2. And the ellipse EIs are constructed such that their centers and eccentricities are same as that of E1. Okay. Center is same, eccentricity is same. And the length of major axis of E1 is the length of, oh sorry, minor axis is the length of major axis of E1 plus 2, EI plus 1. That means if I draw E2, so E2 will be like this. And now if I have to draw E3, then for E3, I'm going to have it like this. And then when we want E4, for E4, we have different color like this. E4 will be here. So this process would go on. Now let's name them. So this is my E1, this here is E2. So let's write down the equation of E1 at least. So E1 is x square over 9 given plus y square by 4 is equal to 1. And eccentricity we can find out E is equal to 1 minus 4 by 9 E square, no? So 9 minus 4 is 5 over 9. So we have to keep using this thing every time. So E is written here. Now x E2 if I write down, then E2 will be simply what? If you see that definition here, the way it is defined. So E2 is going to be x square over. Now here major axis A is unknown. So we need to find out A square plus y square over B. We know it's going to be 4 is equal to 1. But we know the eccentricity. So we can simply apply E square is equal to 1 minus. But now this ellipse is different. So it's going to be A square over 4. So E square is 5 over 9. That means I get 5 over 9 is equal to 1 minus A square by 4. So that means I get 9 minus 5 is 1 by 5 minus 9. A square by 4 is equal to 1 minus 5 by 9. So A square is equal to, now we can write down here. This is 9 minus 5 is 4. So 16 over 9 I get. So this is my A square. That means ellipse E2 is x square over 16 by 9 plus y square by 4 is equal to 1. This is my ellipse E2. Now, if I find E3, then E3 would be, E3 is the green one. So green one, we know A, we do have to find out B square then. So it is simply x square over 16 by 9 plus y square over B is missing there. So we'll write on B square is equal to 1. Now again, same story, eccentricity is same. So E square is equal to 1 minus, now this ellipse is sitting on the x-axis. That means we have to reduce here. B square over 16 by 9 here. That means I get 5 over 9 is equal to 1 minus B square by 16 over 9. So from here I get 5 can transfer this one here. So this gives me b square over 16 over 9 is equal to 1 minus 5 by 9. So b square is equal to 16 over 9 into 9 minus 5 is 4 over 9. This gives me 64 by 81. So therefore E3 is equal to what? So x square over 16 by 9 plus y square over 64 over 81 is equal to 1. Now doing this thing, we get all our ellipses. Now what do we want is, we want the area of each ellipse. So area of ellipse. So area of ellipse is pi AB. Area of ellipse is pi AB. This you can derive using the definite integrals. You can take this point and then just integrate from 0 to this point A, or you can integrate from 0 to B, and this multiply by 4. So 0 to A, y will be simply, we can write down x square over a square plus y square over b square is equal to 1. So y square over b square is equal to 1 minus x square over a square. So b over a times square root of 1 minus x square over a square dx. We can simply integrate this to get pi a b, this entire area. So area of ellipse is pi AB, and that means it's going to be same for everyone except for this A1 and B1, because we have A and B's are varying. So area of ellipses will write down here. So therefore, sum of areas of A is going to be pi into, for the first ellipse A and B, it's going to be 3, 2. So 3 and 2. So for the second ellipse, we're going to get here 4 over 3. Where is E2? Here, 4 over 3 into 2. So 4 over 3 into 2 plus, for the next ellipse we are going to get here 4 over 3 into 8 over 9. So 4 over 3 into 8 over 9. Yes. Now let's go ahead and so on. So we see if this forms something. So this will give me 6 pi, and this would give me 8 by 3 pi, plus this would give me 32 by 27 pi, and then so on. So if I take pi common, then this forms 6 plus 8 over 3 plus this is 32 over 27, and then so on. So let's see what is this pi. It looks like it's a GB basically. So 8 over 3 over 6 over 1 would be what? 8 by 18. So 4 by 9. Okay. And this is 32 by 27 divided by 8 over 3. So, oh, okay, confirmed. So this is an AP, I'm sorry, GB, with the common ratio 4 by 9. So we can simply add it. So this gives me pi times 1 over 1 it's not 1, 6 in here. But the first one is 6, so 6 over 1 minus 4 by 9. So this would give me 9 into 6, 54, 7, 5. So we get this. What is required? We want pi over 5. Oh, sorry, 5 over pi. So 5 over pi we can multiply here. So 5 over pi into sigma of AI would be equal to what? 54. So the answer here is going to be 54. Okay. So that's all for today. We'll see you again in the next session. Thank you so much for watching. Happy learning.